Greetings everyone, welcome to your first lecture as part of the Research and Statistics course for school psychologists. This is going to go a little bit odd sometimes because of the way I have the chapters split up, as you've seen from the syllabus. So there's going to be some bouncing around. Sometimes I'm covering stuff in odd orders. Like today, for example, the lecture that you're going to focus on is the first three chapters the lecture is going to focus on the first three chapters from Rubin and the first chapter from Shadish, Cook, and Campbell. So as a result, there is a little bit of overlap here and there between those books. So sometimes I'm going to be talking about stuff as I'm kind of going through Rubin, but it's talking about things from Shadish, Cook, and Campbell, and vice versa. So just hang in there and do what you can. Again, I would suggest that you actually read the material first before you watch these lectures, but of course a lot of people are going to do them concurrently and those types of things. So do what you can to follow along. I'm adding my own stuff in here as well, and exams will be based off of lectures and books. So that's essentially, it's going to tie in really well here. And make sure you ask questions about anything that doesn't make any sense. Either I've confused it more than the book has, or the book is confusing, or maybe it's something I just glossed over because I would have expected that you've had something along these lines in the past. So let's get rolling on topic number one, which is kind of a fun one, evidence-based practice, because this is something that's dramatically relevant for school psych. So school psych is one of those areas where we're evidence-based, right? Largely speaking, primarily speaking, we use empirically based interventions for behavioral problems or for educational techniques and whatever the case may be. So we tend to focus heavily on stuff that is evidence-based. We'll talk about how that integrates with individual experience and things like that here in a little bit. But it's a good thing. I mean, the fact that school psych is based on empirical principle, or based on things that come from the empirical literature, means that the tools that we're going to use are best practices, right? So the stuff that is available that you'll be looking at in the journal articles and the intervention techniques and the things that you'll use in the field largely come, at least at some level, from empirical research. Oftentimes it's true experimental research, and other times it's quasi-experimental, and we're going to look at a little bit of both throughout this quarter. So the question is, what evidence, right? So what evidence are we talking about? The evidence that we're talking about here is things like as simple as intelligence testing. All of that stuff came out of research. Is it measuring the correct thing? Is the WISC measuring what it's supposed to measure? In other words, is it valid? Is the BASC doing what it's supposed to do? Let's say you've got an intervention or maybe you've got a kid that's violent in the classroom and you're wanting to get the behavior under control. Well, you go to the literature and you find what's been used with other violent children in a classroom, maybe of similar age. So that's the type of evidence that we're talking about. The other stuff that we think about here is the statistics that's related to all these things, and I'm kind of getting ahead of myself a little bit, and that's okay. We'll eventually all catch up with what this terminology means, at least by the end of the quarter anyway. So statistical importance. What I'm getting at here is that when you read a journal article, you're going to look at the different statistics that are part of that, and we're going to go through as part of the Rubin book and talk about those different statistics and how to interpret them and how to understand what's really going on with them. But one of the things that is always touted in the literature is that, it's a significant finding, right? So statistical significance, right? That has a very particular meaning, and it is a very narrow meaning, and it does not mean that the finding is meaningful. It means that that the finding did not occur by chance. All right? In other words, the finding is not random, with a certain degree of certainty, and we're going to talk about those degrees of certainty. So whenever you see one of these journal articles or these intervention techniques that are out there, and you see that, it was statistically significant, that means it's going to work for me. No, it doesn't. That means that in that case, that particular intervention or whatever it was produced changes that were not random changes in the individuals or in the kids playing along there, or working with the researcher. But it doesn't mean it's going to work for you. Okay? It just means that was something that had worked in the past with that particular data set. And you also have to ask the question, was it meaningful? And the example I like to give here is thinking about GPA. Imagine a GPA where we get a statistically significant difference between one university and another university. And if we're looking at graduates, you get thousands and thousands of graduates every year. So it's really easy to get statistical significance. For example, let's compare Whitworth and Gonzaga, and I'm going to make up my numbers here, so don't quote any of these. These are just completely made up. Let's say Whitworth had a GPA, graduating students last year had a GPA of 3.4. And then Gonzaga had graduating GPA average of 3.5. So sure, maybe it's statistically significant. Maybe the difference is significant. It's not due to chance. But is it meaningful? And I would argue, hell no, that's not meaningful at all. The difference between a 3.4 and a 3.5 is very minimal. It's a class, and a slightly better score. But in terms of predictability and this person being able to do their job, I doubt it predicts it. I doubt it has any value at all. So we have to worry about that statistical significance and the statistical meaningfulness, basically the meaningfulness of the findings. And those two don't always match up. Just because something's significant doesn't necessarily mean it's meaningful. And sometimes something's meaningful even though it isn't significant. And that's kind of an odd one to think about, but we'll talk about that later as well. All right, let's look at some themes that are loosely tied. Actually, they're not loosely, they're directly tied into this evidence-based practice stuff, but they're themes that are more directly related to science and the scientific method and those things. And we're going to kind of take a foray into that methodology here for a minute so you can kind of see where that evidence in the evidence-based practice stuff comes in, and then we'll go back and talk a little bit more about evidence-based practices. One of the things that we like to say about scientists and science in general is that it's skeptical. In other words, we tend to question things, question everything. It's sometimes too much, right? But there's even an argument that says we're not as skeptical as we think we are, and that's presented in the Shadish, Cook, and Campbell book. And it's a really interesting argument. I like what they're saying. I do take a little bit of a different perspective on skepticism in science. I think they're taking it a little too literally, in my opinion. But the basic idea is that we're going to question the findings. We don't just completely believe a finding right off the bat. You'll actually want to replicate it and do additional studies, and we'll talk about direct replications and systematic replications. We'll talk about all that stuff as time goes on. But just because it was found once doesn't mean it's found again. And so we tend to take a very skeptical approach at any one data set. And we also tend to be skeptical of our own stuff, at least we should be. In practice, though, that's not always the case. A lot of times people believe that they're the best researcher in the world and that they can't have screwed that up. But in reality, we do screw stuff up all the time. So we have to be very critical of our own data and be very skeptical of our own data and our own research. And then ultimately, we're going to rely on replication. So I take a little different tact on skepticism than does Shadish, Cook, and Campbell. I take a somewhat more pragmatic one, looking at science in a bigger picture, so to speak. Another criteria that we have to have is the things that we do in science must be testable. The questions we ask must be testable. I'm not going to ask questions about, is there life in another galaxy? It's a non-scientific question. We can't answer it right now. Although we're getting darn close to answering some other interesting questions about that stuff that used to be untestable, like is there water on the moon that used to be untestable? And in fact, just recently there was an article posted about how they believe that they may have actually found some water on one of the poles at the moon. It's frozen, it's water ice, but that's a major change. And then I was just reading an article here a few minutes ago talking about snowflakes on Mars. Now it's not water, it's CO2 ice, so it's CO2 snowflakes. But that's stuff that as the technology changes and as science itself changes, we're able to test different things. The idea is we have to be able to imagine evidence, right? That using today's technology and tools and things to be able to move forward with our science. And so that puts it in that testable criteria. Falsifiability, this is one, we're going to come back to this in a little bit, but basically falsifiability simply means that we have to be able to imagine that our evidence can be proved wrong in order for it to be a valid study. It seems a bit odd, right? But the point is that if there's no possible thing that can prove you wrong, then there's no way then chances of you being right are slim to none. Freud, for example, had this problem. Not only were his theories not testable, they were not falsifiable. There was nothing you could do to prove Freud wrong. So that doesn't make it right. In fact, it weakens the argument. Right? So the fact that you could be proven wrong is a very powerful thing in science. And that's a cornerstone of science since Karl Popper kind of introduced it. But it was actually before that, but Popper really formalized it. And I tend to think that the self-corrective nature of science is what falsifiability is all about. Science is kind of the only epistemology that's self-corrective, that if it gets something wrong, it will fix itself. It might take a while, it might take 50 years or 100 years, but it will fix itself. Eventually that evidence will be proven wrong or whatever, and it will change, and we'll understand our world better. And that's that notion of falsifiability coming to life at a grand level, so to speak. The fact that you can prove something wrong is what the fact that something could be proven wrong is what will drive the science forward. If you can never prove anything wrong, then we might as well just give up, because we already know everything, right? That's the basic idea. Another thing, parsimonious here, right? The simple explanations are usually the best. This is also known as Occam's razor, but ultimately what's going on here is that given two different explanations for the same event, the simple one, the one that involves fewer constructs or is less complicated, is likely the one that is correct. There's no guarantee, by the way, that it's correct, and sometimes parsimony is a little overrated in the sense that sometimes things are really complex. We've had some very simple views of physics for a long time, and some of those are coming into question. So maybe it's not as parsimonious as what we originally thought. But it's still something to adhere to and strive to. You don't seek to go the opposite direction. You seek to go in the direction of parsimony and find these simple things. And if you have to modify things based on evidence that's been falsified, then you do. But you don't first start to come up with the most complex thing and work backwards. In other words, we're not going to build Rube Goldberg machines in science. That's not the idea that we're after here. We're going to build simple stuff, and then if we have to make them more complicated, then we will. It must fit with reality. Just because you have your findings doesn't mean those findings fit with the real world. So make sure they do. Sometimes it's interesting when stuff doesn't fit with the known reality, because that does move science forward. But it does have to be explainable. It has to work in our world, so to speak. Right? Serendipity is another interesting one that we have to be aware of, that oftentimes this stuff is just discovered by accident. So we have to be open to new things. So as a school psychologist, you have to be open to new findings and new readings and journal articles and things like that, because you may stumble across something that will dramatically help you in your field. And as a scientist, serendipity is that accidental finding of something very important, and dropping everything and studying that accidental finding. And we can talk for hours about how parsimony has gone through science, let me try that again, how serendipity has affected science. And we can look at Pavlov, we can look at Skinner, we can look at all sorts of people and see how serendipitous findings have changed the field. In fact, it's one of the more important things in science, believe it or not. So scientific method is kind of, these things all lead us to essentially the scientific method, and those are not the scientific method themselves. Those are all parts of things that those are attitudes, if you will, that you have to take in order to implement the scientific method effectively. And later on in the course, we'll start to describe the scientific method in a little more detail, the different procedures that are involved. But just keep in mind that it's not one real clear set of procedures, and each scientist has a little slightly different scientific method. But we all have these sort of things in common, right? And we have certain sets of assumptions that are all in common as well, and that's what drives our science forward. So let's look a little more at the scientific method, something kind of fun that I picked up a long time ago from some other authors. Basically, I want to say that what is the scientific method not? Right off the bat, it's not an explanatory web, right? That's not the only thing that it is. Okay? It is not a descriptive grammar. I mean, we often think of it as the case, where it's just describing things and how you do research, but that's not the case. The same thing with the technological abacus. It's not just something that you used to do research, so to speak. It's other things. It's not just a predictive network. Self-explanatory. It's not an experimental map. This is probably the one that most people think it is. That here's how you do an experiment. You use the scientific method, but that's just not the case. Right? It is not a practical almanac. Right? It doesn't guide you along those lines. At least it doesn't walk you down that path specifically. Right? It's not a moral calculus. It's not an arsenal of methods, of logical, mathematical, or instrumentative. It is all of those things and more. Right? It is like I said earlier, it's these sets of tools. It's an explanatory thing. We pull it all together and we use all these things with these different attitudes, and that helps guide us along in our research and helps guide our science, and it moves us forward. So it's all of these things and more kind of put together and wrapped up into one. And every scientist is a little bit different. Some people use a very rigorous, strict scientific method as an experimental approach, for an experimental approach. Other ones are a little bit looser. Maybe they have lower internal validity or something like that. And different researchers approach this differently. But we do use all these components of it, and we do have all those attitudes that we talked about earlier. So let's switch gears again and go back into evidence-based practice. The idea here is, remember that the evidence came from stuff that from research that we used the scientific method in order to generate the research. And the scientific method is partially comprised of those attitudes that we talked about. So that gets us back to this evidence that we're talking about. Okay? First off, we need to realize it's a process, it's not a checklist. Right? So evidence-based practice is something that you will engage in as a professional. You don't go through, oh, did I do this, did I do this, did I do this, and did I meet my criteria? That's not what we're talking about here. We're talking about how throughout your career you will be using scientific evidence to help influence how you do your job and the types of decisions that you're going to make. Database decision making is something else that is part of this process, right? So there's a lot of things that are incorporated in evidence-based practice, and I borrowed this from your textbook and kind of changed it just a little bit here, and we'll talk about that change. But it incorporates research, right? So that's the stuff that I was talking about. That's where my bias is, by the way. I tend to be, I'm an experimental psychologist, so I tend to be very heavily focused on the research, and I know that's a bias, and that might make me weak in other areas. But evidence-based practice as a whole, as a process, we look at that research, and then, of course, that overlaps with practitioner experience. For example, maybe you've read about a token economy, but you've never used one before. So it's going to be a little challenging the first time you use it. Or maybe you've used one in the past and you're really good with it, so that's kind of be your go-to tool, right? So there's research supporting token economies, but it's also your go-to tool, so you're going to be using it quite a bit. And then environmental constraints. And your book talks about this just in terms of the individual that you're working with. I think of it as much, much more broad than that. It's the individual, it's the context, it's the teachers that you're working with, it's the school district that you're working with, it's the principals, it's the PTA, it's all of those things that might constrain what you can do in order to address the problem that you're trying to address in the classroom or at the institution. So in reality, evidence-based practice is this overlap between all these three things. And then we could continue to draw circles and lines and arrows and all this stuff, and out of there ultimately would come school psychology. But what you would see is that it is about this process, right? This overlap between these things. The environmental constraint stuff is you're only going to be able to do what you're supported with and what might work in that particular context with that particular individual. And you better be able to pull it off. There's the practitioner expertise part. And it better have some evidence for it. So in reality, the evidence-based practice stuff is this small little overlap between all these three areas. Okay. There's steps with regard to evidence-based practice, and QSESA is kind of the acronym that I came up with for this, and I'm sure others have come up with it too. I doubt it's original, but this is just what the way I like to talk about it. Right? So you question, what's that question? That's your first step, right? So what is it that you're looking for? What are you doing a behavioral assessment? Are you doing a cognitive assessment? Are you trying to change a behavior? Are you trying to improve math, education, those types of things? What is it that you're after, right? You have to formalize that, and you have to be very specific so you can go out and search and find that info, right? So find what's been done in the area. So QS, so that's where we're at. Find it. You can use psyc514 at scholar.google.com, various different search engines that have access to these scientific journals is what you're after. Okay? Then evaluate. Okay? From this course that you're taking now, use these skills that you're picking up in terms of statistics and research methods and understanding how to evaluate experimentation and decide if that's going to be an effective tool for you. Is that something that you're going to want to use? If it is, okay, then go ahead and implement it. All right. So in other words, select. So select that one. If after you've reviewed all these things, select the one that's most appropriate for you. Put it into action and then assess whether or not it's working. If you don't assess whether or not it's working, the whole point of evidence-based practice is null and void, right? Just because it's worked for somebody else doesn't mean it's going to work for you. Now, you would automatically ask the question about, did I do it right? If it isn't working for you, you would say, ooh, did I actually do this right? And if you did, great, and it still didn't get the results, that's actually a good thing, because that's something that needs to be talked about, and we need to find those limits of different things. Like, for example, direct instruction. Direct instruction may be an unbelievably powerful instructional technique, right? And it is. It's unbelievably powerful, but does it cover absolutely everything? At this point, the answer is no. So maybe if you try it in a new area, maybe you're wanting to do art or something like that using direct instruction, maybe you find out it wasn't so good using the procedure that you had adopted from author X. Okay, try a new procedure, right? So you got to assess this thing. So this really is a cycle, and if you you do the QSESA, and when you get done with that final assessment, that just leads to another question, right? So say, how can I improve this? How can I do it better? Or is there something else that's equally as effective, that's easier to implement or less expensive or something like that? So in terms of the statistics that we're going to use, there's lots of different types of stats that we'll deal with when we're looking at the evaluation of these criteria, when we're going to evaluate these different articles and the types of statistics that you may run into in the field that you would have to use with, say, your testing and your assessment stuff, right? So descriptive stats, right off the bat, they just describe things, right? They describe a data set. That's your means, that's your medians, that's your modes. We'll go into more detail on that, and of course you've got the Khan Academy to help you out as well. Again, there's nothing fancy going on there. It's just a very straightforward description of of the data that you have. Inferential is when you then go beyond that data. You say, okay, I've got this sample of people, I've got these 25 kids that I've worked with, and I want to infer from that sample to another group of folks. Correlational. These kind of fit both in descriptive and inferential, believe it or not. It really should kind of just go, it does go on its own. It really fits in either one depending on how you're looking at it. Correlation just is a mathematical relationship between two things, okay? Co-related. So if you've got an intelligence test and a behavioral assessment, right? How do those correlate with each other? So co-relate. And again, we'll talk a lot about correlation, but ultimately it's just there's a term for it. I lost the term. It's just a coefficient. It's one number that represents how these things are correlated. And there's a lot of different correlations that are out there, and it depends on the data set that you have. So we'll go over some of those, and we'll at least talk about them. And I'm not going to go for too much in terms of the actual formulas and how do you calculate these different things, because a lot of that is buried into software nowadays, and it's not as necessary as what it used to be. But there's still value in understanding what each correlational statistic or each statistic does. Meta-analysis, this is one I think you guys are going to use quite a bit. It's one I find useful. Meta-analysis is looking at all of the studies in a field. So if you want to look at all of the different ways to work with kids that have ADD, ADHD, and the types of interventions that are available, well, there's thousands and thousands and thousands of articles, so we can't expect you to go through when you're searching for it for your career and read and review all those things. So as part of that QSESA process, but what you may be able to do is find a meta-analysis or a meta-analytic study that covers all those and says, okay, of all these thousands of studies, this meta-analytic study, looks at all those and says which one's the most effective. Right? So which technique has been employed, and how, let's compare that technique to other techniques and which ones were more effective, and so on and so forth throughout the literature. So it's getting a big look, it's a big picture look at the existing research. Regression analysis is another stat you're going to run into quite a bit here, and this is looking at how things are predicted, right? So how do we predict stuff? So if child is engaging in behavior X today, what does that predict in the future? Or let's say they're reading at this particular level today, what does that predict for the end of the school year? So we can use that stuff, and we'll look at how to interpret those. And you've seen this term pop up a couple of times if you've flipped through the site, and I tend to use it. I tend to use this term almost as a joke, but in reality, this is what we actually do. It's an ocular analysis of the data. You're just going to look at it. I once had a teacher that talked about feeling the data, and he would put it up on the wall, and he would project it on the wall, and he would feel the data, right? And the idea is that you're just getting very familiar with it, and you're interpreting what's going on visually. And sometimes, depending on the type of data you have, your ocular analysis is actually your statistical technique, and that's what you use to decide what has actually happened in the study. At the very least, in ocular analysis, will allow you to confirm what your inferential or your descriptive stats are saying, and vice versa. So you can use descriptive stats to confirm your ocular analysis, or inferential stats to confirm it as well too. So you look at all those things together. So we'll always talk about plotting the data that you have if you're generating research. And if you're not generating research, but you have access to some of the data, or maybe what a teacher's doing in the classroom with regards to observation, that would be one way that you would start looking at these things. All right, that's about it for your first lecture. So we'll come back shortly and talk about something else.